Hello guys, welcome to another video. I want to continue talking about the unit circle. We started discussing it in the last video. So this is a continuation of some of the information I've already provided to you. So remember that a unit circle is a circle with a radius of 1 unit. So if you're looking at a radius of 1 unit, and of course the center is at 0, 0, the equation of the circle would be x squared plus y squared equals to r squared. Now, of course, you can also rewrite this as the radius equals to the square root of x squared plus y squared, guys. That's the same thing. So essentially, for every point P, x comma y, when you talk about a point x comma y on the circle, the radius is always 1, guys. So if there is an angle theta in standard position, then this means that sine of theta will equal to y over r. And remember, the radius is 1, so this would actually be y over 1, which simplifies to just y. Likewise, cosine of theta would be x over r, and r is equivalent to 1, so this would simplify to just x over 1, so you would get x. Now, tangent theta is defined as y over x, because you know that's sine over cosine. So guys, pretty much when we're talking about the unit circle, a coordinate in the plane, a coordinate point in the plane can also be expressed as cosine theta, comma, sine theta. So essentially what I'm telling you here is this, guys. Cosine theta is x, sine theta is y if we're looking at a coordinate point. Don't forget, guys, we're in the xy plane, so think alphabetically. Now we're going to go ahead and go back to the unit circle again. So here we go. I'm going to try and draw my best circle, okay? My best circle. All right. Ooh, I hope this works out, guys. It's difficult drawing on here, okay? So let's see. Bam. Okay, best circle, bam, and bam. That's good enough. All right, guys, remember, the circle has the XY plane has 4 quadrants, and they go counterclockwise in a counterclockwise direction, okay? Counterclockwise, okay? Those are your positive angles, by the way. And if you're looking for your negative angles, they go in a clockwise direction, okay? Counterclockwise, positive. Here, let me go ahead and put that there. That's positive. And then if you're going clockwise, that will be a negative angle measure. Now remember, there are 4 quadrants, guys. Quadrant 1 is right there. And when we look at quadrant 1, if we were to plot a point in here, both x and y will be positive. So this means that cosine and sine will be positive. And if we go over here to quadrant 2, okay? Now remember, in quadrant 2, we're looking at a negative x value and a positive y value. So this means if the angle in question is in quadrant 2, the cosine of that angle is going to have a negative measure, while the sine of that angle is going to have a positive measure. And then if you keep going around to the 3rd quadrant, you have both x and y being negative. So that means cosine and sine will be negative. And then, of course, in the 4th quadrant, you want to go ahead and figure it out. So here, the x is positive, y is negative. So it's going to be, hold on a second. There we go. A positive, comma, negative. So cosine is positive and sine is negative. Now, for some reason, they want you to use a mnemonic device to remember in which quadrant, the trig functions are positive. It really doesn't matter, guys. This is good old-fashioned common sense. If you go back to the fact that cosine is x, sine is y, just remember, guys, where you are in the quadrant. The only one I think worth remembering is tangent, but it's common sense. If you're in the second quadrant, y is positive and x is negative. So when you divide, you get a negative. Okay, that's going to happen here too. So here, tangent of theta is going to be negative. And then, of course, over here, because both of these are positive, the tangent of theta is going to be a positive value, while over here, the tangent of theta, okay, because again, both x and y are negative, is also going to be a positive value. Guys, that's it, okay? So 2 positive tangent, 2 negative tangents. To me, that makes a whole lot of sense. But if it doesn't make a whole lot of sense to you, as always, guys, I will be doing additional examples in class. You're welcome to go ahead and ask me. Now, the last time we saw the unit circle in one of the videos, we talked about that the 0 degrees is, ooh, Shazam. Oh, I did not mean that. The 0 degrees, guys, is right here. 0 degrees is right here. Remember, the radius is 1. So over here, guys, this coordinate point would be at 1, 0. All right? X is 1, y is 0. Now, if you go over here, the coordinate point over here, because you're looking at the positive side of the y-axis, this is going to be at 0, 1. And then at this point, you are at 90 degrees. So this is 90 degrees right here. And then 90 degrees is the same thing as pi over 2. And then you want to keep going around the circle. So right here, this point, remember, now we're on the negative side of the x-axis. So x is going to be negative, and then y is going to be 0. Now, this is where we have 180 degrees, which is the same thing as pi, okay? Now, I think I need to get rid of some of these. Let me get rid of some of these because I don't want it to be too crowded over here. Okay, so I'm getting rid of some of the stuff we've already discussed. Maybe it'll just leave a little bit there. Okay, there we go. All right, guys. I think you know the quadrants by now. But if you need it, we can always reference them. So that's 1, that's 2, that's 3, that's 4. All right, there we go. All right, guys. So now let's continue. Down here, when you get down here, you're on the negative side of the y-axis. So this coordinate point is going to be at 0, -1. And of course, right here into, you've gone 270 degrees, 270 degrees. And then the radian measure for this one is going to be 3 pi over 2. And then, of course, when you head back to 0, it's no longer 0 degrees because you're making a full circle. So it's now 360 degrees. And 360 degrees will become 2 pi. And there you go. Just like that, guys. All righty. So let me go ahead and see what I can do about erasing some of this. Okay. I'm going to erase some of that because it's a little busy. Oh, Lord have mercy. Okay, that's not going to work. Okay. Let's put this back then. If it's not going to work, we're going to put it back. All right, there we go. Okay, so we're going to go back. Now, guys, the next part I want to do is tackle quadrant 1. Okay, so here we're going to look at the main angles, the reference angles, okay, and their corresponding cosine value and sine values. Now, remember, I gave this to you as well in a chart, and the chart, guys, is very important. It's key for you to do well with the circle. Now, we're going to take this, guys, and break it up into 3 sections. We're going to take the first quadrant and break it up into 3 sections, okay? And so if quadrant 1 is a total of 90 degrees and we break it up into 3 sections here, we're going to go ahead and break it up into a 3. Ooh, Shazam. Oh, Shazam. I didn't mean that. Okay, let's try this one more time. Hopefully this works, guys. Okay, so we're going to go to 30 degrees. So this is our 30-degree angle here. Now, guys, remember, we talked about the 30-degree angle, and that's the same thing as pi over, remember, 6. Then we're going to go to the 45-degree angle, And for the, I think that's a little too high. So let me go ahead and redraw that. 45 should be towards the middle, the 45-degree angle, and then the 60-degree, okay? So for the 45-degree angle, guys, remember that is equivalent to pi over 4. Pi over 4 for 45, pi over 6 for 30, and then for the 60 degrees, it's going to be pi over 3. All right. So now I think my pen is really, really too not small enough to be able to write in here. So, okay, I'm gonna try and squeeze as much of this as I can. But guys, if it doesn't work out, I'm sorry. I'm trying my best here to get it to fit into here. And so, okay, well, remember, we talked about the measurements, okay? And I'm getting to a point here. Just hold on a minute. So guys, over here with the 30-degree angle, what you have to realize, the coordinate point P on the circle for this one is going to be, let me see here. Let's see how we're gonna put it in here. Okay, I'm gonna try and squeeze it over here, guys. So it's gonna be radical 3 over 2, comma, positive 1/2. Now, let me say this. Radical 3 over 2, comma, positive 1/2. That means that the cosine of 30 degrees or cosine of pi over 2, pi over 6 is going to be radical 3 over 2. And it's positive because we're in the first quadrant. And then the sine of 30 degrees or sine of pi over 6 is going to be 1/2. Now, if you want a derivation of all these things, we could go ahead and talk about it further. It's hard to do it right here on the small screen size. Okay, this is really, really small, guys. Okay, I think my brain is getting foggy because it's getting really late. Okay, so anyways, guys, the 45-degree angle, it is the point, the coordinate point for on the circle is going to be radical 2 over 2, comma, radical 2 over 2. As in, if you're asked to find the cosine of 45 degrees or cosine of pi over 4, it's going to be radical 2 over 2. And if you ask to find the sine, it's going to be radical 2 over 2 as well. Now, of course, this goes back to the 45, 45, 90 triangle relationship, and then the 30, 60, 90 triangle relationships. Remember, when you have a 45-degree right, a 45, 45, 90 right triangle, guys, if one angle is 45 and you know it's a right triangle, automatically that makes the other angle 45 degrees. So obviously there's two congruent angles. So both X and Y are going to be the same values, okay? So then once we get to the 60 over here, okay, let me see how I'm gonna squeeze this one in here. Once we get to the 60, guys, this is gonna be 1/2, comma, the square root of 3 over 2. So the cosine of 60 degrees or pi over 3 is going to be 1 over 2. And then the sine is going to be square root of 3 over 2. Now that's the first quadrant. So guys, here's the point I was trying to make. What happens is that these same degree measures, they repeat all around the entire circle, So guys, essentially, what I'm telling you, I should erase this. Let me try this one more time, okay? All around the entire circle. So what I'm trying to tell you is this. Once you know these basic angles, the 30 degrees, the 45 degrees, the 60 degrees, you just keep using those same angles over and over again. What is going to be the difference? The difference is going to be the signs, whether it's going to be, the cosine is going to be positive, negative. Same thing with the sine. Is it going to be positive? Is it going to be negative? Same thing with tangent. Is it going to be positive? Is it going to be negative? Depending on which quadrant you're in, that determines whether it is going to be positive, negative. So guys, if we go over here to 120 degrees, by the way, 120 degrees as a gradient measure is 2 pi over 3. And 2 pi over 3, if we're looking at it in terms of the reference angle, if we're to drop the reference angle to the x-axis, guys, you subtract 120 from 180. 120 from 180 leaves you with 60. So 120 degrees has the same reference angle as 60. So since it has the same reference angle as 60, then we could go ahead and use the information about the 60-degree angle in the first quadrant to come up with the coordinate right here, okay? That's going to represent 120 degrees. So here at this point, what do we know? We're in quadrant number 2. In quadrant number 2, we know x is negative, y is positive. So this coordinate, okay, we're just going to use the information from the first quadrant for the 60-degree angle. This means that x is going to be negative 1/2. And then, of course, the y value is going to be a square root of 3 over 2, positive. Notice, guys, it's the same thing. What is the difference? The sign, because cosine in the second quadrant is negative. And you keep doing this for all the other angles. So if we were to go to the 45-degree one, okay, which is 3 pi over 4 for 135 degrees. Let's say we drop it over here, 135 degrees, okay? That's gonna be, let me see here. I didn't forget this, okay? That's gonna be 3 pi over, I think I said the wrong thing. Let me make sure here. 3 pi over 4, yep, 3 pi over 4. And so, guys, right here, 3 pi over 4 has the same reference angle, guys, 135 degrees. If you take 180, you minus the 135 degrees, that's going to leave you with 45. So its reference angle is 45. So now the question is, the coordinate point, is it going to be a negative cosine, positive cosine? What is it going to be? So because you are in the second quadrant, cosine is negative, sine is positive. So this one is going to turn out to be a negative radical 2 over 2. Okay, if I could only get this to write, and it is not writing. Okay, so hold on a second, guys. All right, so over here, this is going to turn out to be radical 2 over 2, negative, because we're on the negative side of the x-axis, and then radical 2 over 2, positive for the y value. So guys, what I want you to notice is that these things, they repeat. They're repeating. What is the difference? The signs, guys. The signs are changing. So as long as you're changing the signs, you're good, guys. So essentially, the unit circle is very easy for you to understand. And so once you figure out the first quadrant, you practically figured out all the other quadrants, the other 3 quadrants. So what is really important here, guys? That first quadrant right there. So if you know what's happening in the first quadrant, then that's going to help you to figure out what's happening in the second quadrant, third quadrant, fourth quadrant. And what do? We use the reference angles. Use the reference angles. What are the reference angles? That's number 1. Okay, so you want to sketch the reference angle, find your reference angle. All right, that's the first thing you need to do. Once you figure out what the reference angle is, that will take you back to the first quadrant. And so once you go back to that first quadrant and you relay it to its reference angle, that is definitely going to help you to figure out, okay, what's happening. The next thing you need to do is to find the sine, cosine, and tangent. And of course, the last step is to determine the sine. What is the sine? Okay, find the sine. Adjust your sine. What's the sine? Okay, here, let me put find the sine. Okay, find, there we go, find the sine. And what I mean by this, and this is not writing over here very well, okay, find the sine, as in positive or negative. Find the sine, guys. So essentially, that's it, guys, okay? Find your reference angle so you can relay it back to the first quadrant. Find the sine, cosine, tangent. And then once you figure out the sine, cosine, tangent using the reference angle from the first quadrant, determine the sine. Is it positive? Is it negative? And guys, that's the extent of this, okay? When you're working through these problems, remember, This is all common sense, guys. This is information that you learned back in previous courses, and you're just adding to it. You're just building on it. When did we learn the XY plane and the different quadrants in the XY plane? Probably in 6th grade. Basic algebra class, we learned about this. So here we are at the trig level where we are adding to the same basic knowledge. So you've got this, all right? Now, we'll go ahead and continue discussing this in class, but I think I want to do a couple of examples with you guys before I go ahead and close out this video. So here's the question, guys. The question is this. Use a reference angle to find the exact value of the sine, cosine, and tangent of 225. Okay. Use a reference angle, all right, to find the exact value of the sine, cosine, and tangent of 225. First, let's go ahead and sketch this out, okay? We got to find our reference angle. So think about 225 degrees. That is past 180 degrees, okay? So guys, it's exactly 45 more than 180 degrees. So we were in the 3rd quadrant. So we're about here. So this represents your reference angle, okay? That's your reference angle. Remember, you have to drop that perpendicular to the x-axis. So that's your reference angle, guys. So since you have this reference angle here, which is a 45-degree angle, and remember, go back to that 1st quadrant. The 1st quadrant, 45 degrees had a coordinate point of radical 2 over 2, comma, radical 2 over 2. So we're going to use the same information here, okay? Radical 2 over 2, radical 2 over 2. Now, remember, sine is the y value, and then cosine is the x value. And so, because you are in the 3rd quadrant, both x and y are negative. So that means you're going to have a negative radical 2 over 2 for sine of theta and negative radical 2 over 2 for cosine of theta. And then finally, what's tangent of theta? Remember, tangent of theta, guys, is the ratio of y over x, or sine theta over cosine theta. So if you're doing sine theta over cosine theta, what is that going to simplify to? It is simply going to simplify to negative radical 2 over 2 divided by negative radical 2 over 2. So you're dividing two negatives. So what is it going to turn out to be? A positive 1. And guys, just like that, you're done. That's all you're doing, guys, okay? I think I'm going to do one more, and this time I think I'm going to do it in relation to, let me see here. Yeah, why not? Yeah, sure. Let's go ahead and do that. So I am going to do it with a radian measure. So let's go ahead and use a radian measure. So this time it says, use a reference angle to find the exact value of 10 pi over 3. 10 pi over 3. So you're going to find the sine, cosine, and tangent. Now, think about it. 10 pi over 3, guys, if we do a quick division here, 3 goes into 10 pi is going to be 3 pi with what left over? Pi over 3 left over, okay? So essentially, we are going one full circle, which is 1 pi, and then another half a circle, which is pi, then we get to pi over 3. Shazam, that's not a very good one. So if we want to do a quick sketch of this, realistically, this is what the angle would look like, okay? And remember, pi over 3 is 60 degrees. So this is where we're going to end up at. Now, drop your perpendicular to the x-axis, okay? So this would represent your reference angle. So there's your reference angle, guys. Now, we're talking about pi over 3. And again, you want to relay that to the 1st quadrant. In the 1st quadrant, pi over 3 represents 60 degrees. And pi over 3 was 1/2, comma, radical 3 over 2. So now you're in the 3rd quadrant, guys. What is the difference between the first quadrant and the third quadrant? Both x and y are going to be negative. So for this particular problem, sine of theta is going to be a negative radical 3 over 2. Cosine of theta is going to be a negative 1/2. Why negative? Because we are in the third quadrant. The reference angle is in the third quadrant, guys. Okay? So now the tangent, be careful with the tangent theta, because remember this is y over x, or sine theta over cosine theta. So you are simplifying radical 3 over 2 divided by negative 1 over 2. So essentially, guys, the 2's, they cancel out, leaving you with what? A positive radical 3. Yeah, because a negative divided by a negative is a positive. And just like that, guys, okay, we are done with this. So you're using the reference angle to figure out sine, cosine, and theta. Now, I am going to discuss some further problems in class, but for now, we are done. So I will see you next time, guys. Bye.